All right, let's do this tutorial. So if you read this question, see if you can do it on your own. A child sitting 1.1 meters from the center of a merry-go-round moves with a speed of 1.4 meters per second. First, we're going to calculate the centripetal acceleration of the child. Then we're going to calculate the net horizontal force exerted on the child if the mass is 25 kilograms. So a couple things to remember is this centripetal acceleration defines the direction of the acceleration. So let's see. For part A, we're going to find the centripetal acceleration. Now the centripetal acceleration depends on the tangential velocity and the radius. So if you imagine the picture, we've got a merry-go-round. And maybe there are bars here. And there's a child sitting on this merry-go-round. And holding on for dear life as we spin round and round. Now, we know that r is the distance we're sitting, and we know the velocity is the 1.4 meters per second. So the acceleration, v squared over r, can be substituted and have a sub c is equal to 1.40 squared divided by 1.10. That'll be our acceleration. And I get 1.78, and this would be in meters per second squared. Now this acceleration is towards the center because it is a center-seeking acceleration. So if we think about looking at a overhead view of this merry-go-round, and you've got the child sitting there, here, maybe there's the child, then the center being here, there would be an acceleration towards the center that's causing the velocity that is tangent to the circle to change, because in the next second or so it's going to be this way, and then it's going to be this way, and then it's going to be this way. So all the time the acceleration is it's changing the direction of the velocity by pointing towards the center. So my acceleration is pointing towards the center in all those cases. So that means that this direction that's asked for in the question is towards the center, or towards the center. Now the next part is asking us to find the net horizontal force exerted on the child. So thinking about the acceleration and it pointing towards the center, that would mean that our force must be towards the center. So if you imagine here's the child sitting on the merry-go-round, and there is a force from the merry-go-round up on the child. We call that normal force from a surface onto an object. There would be the weight force acting on the child, F sub g. But then something's pointing towards the center of the circle here, and that would be like maybe a friction force, something, or maybe the arms are holding the child from from sliding, but this is some force, some friction force or tension force in the arms of the child, keeping the kid from flying off the merry-go-round. So, if that is what I'm looking for, and I'm looking for the net force, well, the net force in the horizontal direction would be equal to ma, and the acceleration in the horizontal direction is this center-seeking force, center-seeking acceleration, and so we just need to solve for that. So the net force would be 25 times our 1.78. So 25 was given in the problem as the mass of the child. So that gives us 44.55 newtons or thereabout. And that is also pointed towards the center. So overall, we found the centripetal acceleration of the child on this merry-go-round, and by using the equation that the centripetal acceleration is v squared over r, substituting in the speed that we were given in the problem and the distance from the center we were given in the problem, then we were able to solve for the net horizontal force on this child of mass 25 kilograms by using our sum of forces is equal to ma, and in this case the acceleration is that center-seeking acceleration. This would be a reasonable free body diagram of the forces acting on the child. The weight is down, the normal force is up, and some force, probably friction or maybe tension in the arms, is pointing towards the center. And so that net force is towards the center of the circle. Now let's try another one.